Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Najwa binti Azlan. My matrix number is DE240083, and I'm going to talk about our introduction. This lab focuses on learning how to use MATLAB Simulink to simulate and analyze electronic circuits. In this activity, we will design a circuit, change some of its value like resistor, voltage, current, and observe how those changes affect the voltages at different points in the circuit. We will use MATLAB's GUI and Simulink to run the simulation and record the results. This helps us understand how circuit work and how MATLAB can be used for electrical analysis. That's all, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zainatul Fitri binti Abu Sama. My matric number is DE240039, and I will explain about calculation. But before I start with the calculation, let me explain the circuit first. So this is a DC circuit with 5 resistors, 1 voltage source, 1 current source, and 1 control voltage source. Dependent control current source. Dependent control voltage source. Here what we have R1, which is the value is 4 ohms connected to V1 to the ground. And then R2 is 6 ohm between V1 and V2. R3 is 8 ohms between V2 and V4. R4 is 8 ohms between V2 and V3. And last, R5 is 8 ohms between V3 to the ground. And then we have a voltage source, which is V between V1 and V3. A current source, 3 ampere entering the circuit. Another current source, 8 ampere, which is I call the I, symbol I, flowing out to the current to the circuit. And then lastly, a control voltage source, which is labeled 2VA, where VA is V3 minus V2. There are 4 nodes in this circuit, which is V1, V2, V3, and V4. Because there is a voltage source between V1 and V3, I can apply the nodal method directly. I need to use the supernode method. Okay, now I will explain about step-by-step calculation using method supernode. So why I use supernode, which is because of the voltage source between V1 and V3. When 2 nodes are connected by a voltage source, we group them into one supernode. So in this case, I group nodes V1, V2, V3, and V4 together in the supernode. So now I will apply KCL to the supernode, which is Kirchhoff current law. So KCL says the sum of the current entering the node equal to the sum of the current leaving the node, which is the easy way to understand, which is I in equal to I out. So I calculate the current through this resistor from V1 to the ground, which is I get V1 over 4. From V1 to V2, I get V1 minus V2 over 6. And from V2 to V4, I get V2 minus V4 over 8. From V3 to the ground, I get V3 over 8. Then I add the current source, which is 3A is entering the node, and the second one is 8 ampere, which is I call I, is leaving the node. So I write this equation, V1 over 4 plus V1 minus V2 over 6 plus 3 amperes plus V3 over R5 plus V3 over V2 V3 minus V2 over 8 equal to A. So after simplifying, I get my first equation, which is 5 over 12 V1 minus 7 over 24 plus V3 over R5 plus V3 over 8 equal to A minus 3. So that is my first equation. Okay, the next one, we need to find the support equation. Because there is a voltage source between V1 and V3, I will write a support equation. So my support equation is V1 minus V3 equal to V. This is my second equation, and it shows the voltage difference between V1 and V3. So now I will focus on node V2 and apply KCL, okay, which is Kirchhoff current law. So the current flow from V2 to V1 through R2, which is 6 ohms, and we will get V2 minus V1 over 6. Second, from V2 to V4 through R3, which is 8 ohms, we get V2 minus V4 over 8. And lastly, from V2 to V3 through R4, which is 8 ohms, we get V2 minus V3 over 8. So I will write the equation from that current flow I mentioned before. So we get V2 minus V1 over 6 plus V2 minus V4 over 10 plus V2 minus V3 over 8 equal to 0. So we need to simplify all that equation into a single equation. So after simplifying, I get negative 20 V1 plus 47 V2 minus 15 V3 minus 12 V4 equal to 0. That is my third equation. So now we need to find the fourth equation. So from that circuit also has control voltage source, which is we call it 2VA. So that is V4, the fourth equation. We need to find the equation. So VA is the voltage difference between V3 and V2. So from the circuit, we know that V4 equals 2VA. So VA, where we need to find VA, which is V3 minus V2. So because the VA is the voltage difference between V3 and V2. So we need to minus V3 minus V2. So after simplifying, we get negative 2V2 plus 2V3 plus minus V4 equal to 0. That is our fourth equation. So the last step calculation about supernode method, we need to form all four equations into a metric forms. So in metric form, we need to put four equation into AVB, which is A is the metric of coefficient, V is the voltage vector, which is we need to put V1, V2, V3, and V4. And last, B is the result or constant vector. So from four equation, you need to put all four equation into the metric form, like I show in the picture below. So exactly like that. This metric is ready to be solved to find V1, V2, V3, and V4 using software MATLAB. Okay, lastly, the conclusion about the calculation, we need to summarize. I use the supernode method because of the voltage source between V1 and V3. And then I apply KCL, Kirchhoff current law, to get the main current equation. I also add a support equation from the voltage source, also an equation for a control source. Then lastly, I arrange everything into a metric form. So this is the finishes of calculation manual part. So the final step to find which is solving the matrix and finding the value of V1 to V4 was done by my teammate using MATLAB. So that's all from by my side. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. My name is Nur Shahida binti Zamali. My matrix number is DE240112. And today I want to explain about the GUI, coding, and also the Simulink. For the GUI, we put the question circuit for the question and two push button, which is calculate and exit button. When we put the value of R5, voltage and current, and push the calculate button, we will get the value of V1, V2, V3, and also the V4. For an example, we put the value of R5 as 5, voltage as 5, and the current as 5. And when we push the calculate button, we will get the result for V1 as 5.66, V2 as 1.95, V3 as 0.66, and also the V4 as negative 2.60. And when we push the exit button, we will get exit from the question. Now I will explain about the coding. Coding for the image question, I only put img equals to imread. Meanwhile, for the push button, which is calculate button, I put AA to store the value of voltage, BB to store the value for current, and RR to store the value of R5. Then I put the matrix form as that we get from the calculation earlier. And lastly, the exit push button, I only put close function. Finally, I will explain about the Simulink. For the Simulink, this is the circuit that we have done. Same as the GUI before, I also put the value of R5 as 5, voltage as 5, and the current as 5. And when we run the circuit, we will get the value of V1 as 5.656, V2 1.953, V3 0.6559, and the V4 as negative 2.595. And when we compare the both result GUI and the Simulink, we will get the result is almost the same.
My name is Nur Ashiani binti Zaziri. My matric number is DE240053. So I will continue with the last part, with each conclusion. Through this project, we strengthen our understanding of key electrical principles such as nodal analysis and voltage-current relationship by applying them in real work. So we use the MATLAB, Simulink, and GUI development intensively, each offer a unique strength that exchange our problem-solving capability. First, we use manual coding when we need the precision and full control over the calculation and logic. Second, we use for the Simulink for visualization and structure clarify, so that can help us for model system intuitively. And third, we use the GUI development to create a user-friendly interface, so can making our tools more interactive and accessible. So throughout the process, we emphasize cross-verification, consistently checking results across different tools to ensure accuracy and build confidence in our solution. Beyond technical skill, we also develop a career skill, working as a team improvement our collaboration and our communication, also managing deadline helping us enhance our management. That's all for our group. Thank you.